Hello, welcome to Flipped. So today we are on kinetic particle theory, focusing on the states of matter. Kinetic particle theory really just means to use the movement, kinetic, of particles to explain why certain states have certain properties. And there are three states. First is the solid, second is liquid, third is gas, and each state has its own physical properties. Let's start with solid. So in solid, the particles are held in fixed positions in orderly arrangement because of strong intermolecular forces. So you can see that between the particles, let's do it in red. So all these red are the intermolecular forces of attraction. So you see that they cannot move much because all these red color forces is holding them together. And they possess very little kinetic energy and can only vibrate about their fixed position. Let's take a look at this guy here at the corner. It can only vibrate like this, very, very small movement. It cannot move all the way here or all the way here. This is not allowed because they are in solid position. They can only move about their position. They cannot go all the way up as they want to. And due to this, it gives them a fixed shape and volume. Because you can see that they are arranged like this, they cannot move much, and so their shape is fixed, and so is their volume. And this leads to high density because they are so closely packed together. And also they cannot be compressed. Like a normal solid, right? You cannot compress a solid because it has a fixed shape basically. Next, we move on to liquid. The particles in liquid are free to move about throughout the entire liquid, but they are still held together closely by strong intermolecular forces. So what do I mean? So you can see that between the particles, there are still intermolecular forces, or this red are the forces here between them that's holding them together, although not as tightly as in a solid, but they are still close together. But now the particles can now slide over one another. So for example, for this guy here, let's put this guy in blue. So this blue particle here, if it wants to travel to here, no problem. It can just slide about in the around this liquid structure. So for example, in a puddle, if the molecule wants to travel from here to here, no problem. It just has to slide past all these particles to get to here, no problem. Because they are free to move throughout the entire liquid, but there still exists some force of attraction between them. And due to this, they have no fixed shape because the particles can move about, right? But they have fixed volume. So if my puddle of water is 25 cm3, ignoring evaporation and all the other processes, it will always stay 25 cm3 because the volume is fixed. And because the particles are so closely packed, they have high density. But the thing is that they cannot be compressed, because even though the particles can slide past one another, there's still no space between them. There's so between two particles, let me just zoom in maybe. I zoom into these two particles. You can see that, although the particles are not arranged as neatly as in a solid, you can see that there's still no space between them. It's still minimum space between them. So these are all the attraction forces. You can see that there's no space between them, although in theory the distance between the particles are slightly greater than solid. But for simplification's sake, just assume that there's no distance between them, and so they cannot be compressed like in solid. Let's move on to the final one, which is gas. In gas, the particles are free to move about randomly at high speeds. So this is a particle, this is a particle. All these are individual particles. They can move about wherever they want to. And this is because they are so far apart from one another with negligible intermolecular forces. So let's compare that with with liquid. So you can see that between liquids particles, there's a molecular attraction. But in the case of the gas particles, the attraction is so weak, that as if nothing is holding them together. So they can just fly about and move about wherever they want to. And that is why they have no fixed shape and volume, and they have low density. Low density because they are not closely packed anymore, and no fixed shape and volume because they can take on any shape, and volume of the container as they want to. And so that's why if you have a gas syringe, for example, let me draw a gas syringe here. You have, for example, a fixed volume of gas, but you can always compress it to change the volume of gas. You get what I'm saying? So for example, if I have, 25 cm3 of gas, I can always just compress a little and to force it to be 20 cm3. No problem, because the space between the gas particles are so large that there's room for adjustment. Okay, and sorry, this one is can be compressed. Should not be cannot be compressed. Okay, and that is why they can be compressed. Okay, because of its unique property of the particles being so far away from one another. Okay, and that is all for solid, liquid, and gas states.